Hi everyone, good evening. So I'll not waste more time and we're gonna get started now. I can see there are 32 attendees there into the session. That's great. Others are also most welcome. They can join during the session. So thanks everyone for joining. Firstly, I would really appreciate that you guys took time and joining this particular, series of session where we will be discussing about different topics related to the databases. And the end goal for this whole program is that it's a free educational course as an initiative from GSUL. And you must have received invites via LinkedIn. You must have received invites by organizations, and today everyone has been invited into the series of training. This program going to consist of around more than 300 hours of training and multiple case studies. If you'll ask me in total, we are expecting it to run till 9th of January next year because we are doing 2 hours a day. We will be having multiple capstone projects. We will be having, multiple case studies. Every day we'll be having the quizzes, etc. So considering that, as I said, this is going to be a recorded session. And just to give you a background about what all you're going to learn during this 350 plus hours of training, I'm going to present my screen. From there on, we'll pick it up. Okay, so I would expect participants to be on mute to maintain there is no, echo or any background noise from anyone's side. So if you can see that this is the complete module which you will be all going through. And about me, I'm Sahil. Basically, I'm the founder and CEO at GSUL. Couple of you might have met me during, LinkedIn interactions or during our free webinar series, or we have delivered a lot of trainings for your respective organization, or you have been into my any of the previous training session through your corporate. So a couple of you might have known me already. If you don't know that, I am a guy with a more than a decade experience delivering trainings, implementation, consulting projects on the different case studies, etc. The initiative of this program is as GSOL has completed it 3 years, so now it's just all about giving back to the society, whatever I have learned from all these different years. So considering that this program has been developed, now I'm not taking much time about the introductions here. You can see, so considering today, this program is all going to about the databases as the starting point where we will be learning for the 10 hours of duration, and this has been developed into the 3 modules. Each module will be having a capstone project at the end. And starting the beginning of the project is going to be from, let's say, 13th June, and every day we will be working 2 hours into the same. You will be getting the emails with the day-wise agenda. Shortly, the candidates who has registered for the today's session, they will be having the day-wise TOCs with them so they can see what they come up prepared with. We will be sharing a lot of materials also with you in terms of PPTs, PDF guides, hands-on experience. And we will make sure that whoever is joining this session, as there's no intention to charge anyone or use it for any. Yes, it would be on our website. It would be on the YouTube channels later. The intention purely here is to give back to the society and make sure that we will add more skilled people into the society. So that's the whole idea, and that's why this particular bootcamp program has been designed. We will be primarily focusing on the databases. We will be discussing on the advanced technologies like Snowflake, Python. We will be talking about the ETL concepts. If someone is aware about ETL, what it is already, then that's great. If not, then you will be learning a lot from this program. We will be talking about advanced concepts like IACS, Power Center, Power BI, Tableau. And trust me, if you will go for any of these programs from any training institute or any corporate, you will be paying literally in lakhs. Why I'm highlighting this is just so that you can take this, course as a free. It is a free, but does not mean that it is not really going to have any quality. Trust me, you will have a lot of quality material which is going to be shared with you. And after the couple of days, I would expect, to get trained and if you spread mouth of word in your organizations as well, and showcase the quality about it. All right. So that's about it as an introduction, guys. And as today is the first day, we are gonna keep it bit slow. If you have any questions, anyone, please feel free to raise your hands. Feel free to put it in over in a chat window. Do you see already you have? Okay, and post this session, the recording is gonna get uploaded to platform, and you'll be having the link as well. But however, I would expect everyone to be there for this 2 hours of the training today and in the subsequent sessions as well. Right, so I'll not take much time from here now, and I would be jumping directly to the today's topic, which is about introduction to the databases. So considering that what is a database is a beautiful thing to understand. And as I said in the beginning, we will be getting a lot of PPTs and everything also with you. So we will be discussing about it. And at the same time, you will be having a hands-on exercise also, which I will be performing. And at the same time, you will be allowed to do it at the same time, and will be giving you the option to submit as well, which can be evaluated, and your details, your marks would be shared with you. All right. So, as you know, this bootcamp program is sponsored by GSUL. We are an edtech organization based out of Bangalore. As earlier said, couple of you might have already worked with us. If you are new, you please feel free to visit our website. There are multiple programs which we are doing at the same time. As I know, the audience is a larger audience coming from the different industries, platforms. If you have any feedback, suggestions for us, feel free to share. All right. Considering that, today is all about, database, and that's the first topic in this particular series, which we are going to start with. Now, the question arises is why database is the first topic which I have selected. I would have selected any other topic. Okay, but now what happens is I'll talk about my personal experience over these years. Okay, so now when I've started my journey over the 10 years back, someone has given me advice, learn databases. Okay, because whatever the platform you will choose, right, either you're a Java developer, you're a web developer, databases is something which is going to be the backbone for any platform. You have to develop an application, you need a database to store the data. You need to develop a solution which is a data-driven centric. You need a database to store the information. So anywhere when today data is generating into the different forms. Okay, data is being generated, structured data, semi-structured data. Data is being generated in form of audio, video. Okay, there are hundreds of ways in which data is being generated. But now, considering all those different platforms, we would be needing something in which we can store that information, right? So example, let's say this video we are talking about, right? So this particular training. So now during this training, we are generating the data now in form of audio and video. So we would be needing a platform which can store this information. So let's say we have developed the OneDrive. Microsoft has developed the OneDrive now, which can store the data into the multiple formats. Okay. Now consider that you have the data, which is our traditional data. So when I would say a traditional data, I mean that I believe everyone have used Excel, by this particular time we are speaking. So Excel, how does the Excel stores the data? Excel stores the data in a very structured way where you have a rows and where you have rows and where you have the columns. So example, if I'll open this particular Excel book on my screen now, I can see there are rows which has been represented as 1, 2, 3. Okay. And there are the columns which is represented as like A, B, C, D, E, F, right? And there are the numerous columns which we have. Now considering this,
Sai,
yeah, yes,
Bhavani,
Sushri.
I'm unable to see the screen. Is it happening for others as well? It's black screen for me.
Okay.
No, Sahil, you can see it.
Okay, then I'll
I
relog in.
can see the screen.
Okay, okay, I'll relog in again. Thank you.
Right,
I
sure.
think someone mentioned that no.
Yeah, meaning it's not black screen for them. Just
Okay.
please
Okay.
relog it, so Shri, it would be good. All right. So as I was explaining about the database, right, we know that database is a place where you store the data. Now, we are generating the data into the different formats. We are generating the data, structured data, where now what is the structured data? Structured data is the data where you have, rows and columns, fixed format basically, right? And at the same time, then we have the data where there is an unstructured example. You have the data where there can be a header, where there can be a footer, there are tuples around it. So basically, when you have to store the data, you need a storage mechanism. Okay. And when the database comes into the picture, the database is going to store the information in a systematic manner so that readability of that information becomes easy. Okay. What does that mean? Example, consider that let's say I have to develop one, candidate Excel. Okay. Where I would have the information of the candidates like candidate's name, what is their email ID, what is their experience, what is their gender, what is their age, what is their qualification. So in this set of information, I can see I have 6 columns with me. As a part of these 6 columns, if I will enter the data here, let's say candidate name is Sahil, his email ID is xyz@gmail.com, he's having 11 years of experience, gender is male, age let's say 40, qualification is graduate. So considering this set of information which you will have, you can see the data which we are storing is in a structured format. So this structured format of the data helps you in organizing the data in a better way. Now, instead of storing the data in this particular structured way, if I would store the data where I have the information, but not in a structured way. One row is being aligned to somewhere, another row is being aligned somewhere else. So keeping this in mind, what happens is now when the information is not stored in a structured way, that becomes the unstructured data. There are the different examples which is available in today's world, which about the unstructured data. Firstly, we are focusing on simplifying the information and focusing on the structured set of information, and that's where we are going to talk more about the structured database. Now, why structured databases? Because database is made up of two terms, data and a base, right? Now, if I'll explain to you what is data, data is basically a collection of the information. Now, what is the information? Information is basically collection of the different data points which is available to you. Okay. So now when we have a data, basically data has been categorized into a raw data. Okay. What is the raw data is? Data has been categorized into raw data, and then we call it as the meaningful information. We don't call it as the meaningful data, but we call it as meaningful information. Now, what is the difference between these two terminology? Raw data is something which is generated by the system. Example, let's say in this past half an hour of the video, I would, I'm speaking from the last 20 minutes or so. So before that also there was a recording which was started, okay, but that was a blank recording. There was no information was coming out of it. So we have generated the data, but there was no meaningful insights about it, right? So considering that thing, when we have the information, okay, which gives us some meaningful insights about it. Consider, let's say, you are dealing in a retail sector, and as a part of the retail sector, you are dealing with, multiple customers. Okay. Customers in the sense, let's say you and me are a customer. At any given point of time, you like individuals like you and me are the customers, right? So when a customer goes to the market, what they do is they're going to capture the customer information in terms of, how many customers has entered the store. So we are capturing the data there as well. But until unless that customer has done some shopping, has done some purchases, that's a no more meaningful information we are able to get out of it. So that is where, when it comes to the raw data and the meaningful information, that we are going to apply the certain logics on that particular data set, which is going to provide us the hidden and the meaningful insights from our data. And once the data we have, then we can do the analysis on the data, and then we can provide the meaningful, reports to our end user as well. So when we talk about this whole concept of cloud business intelligence, right? The idea is that on the end, we want to find the meaningful insights from that. And when we to find those insights, we would be using the different methodology, we would be using the different tools and platforms, and the database is the one where first we're going to store the data. Then the techniques which we are going to apply to convert that raw data to the meaningful information is going to be part of, our ETL techniques, Python, etc. And then from there on, when we do the analysis using the different reports which we are going to build, that's become as the part of our, full stack information what it will have. Okay, so now coming back to the point of the databases, what we have, as we say, we have the different variety of the databases. We will store the data in form of a structured databases, semi-structured databases. Okay, there are the different database providers are there, meaning. So now Excel is a tool which is being provided by the Microsoft. Similarly, there are the different tools are available, tools in terms of if you have heard the company names like Oracle, or if you have heard the company's name like Postgres or Snowflake. So these are the different companies which has provided us the different tools and the platforms which can be used to store the information. Now, why would we need these different platforms? Okay, why can't I store the information just in a notepad, which comes, very handy with my Windows system or with a Linux system or with the Mac system? So eventually, when your data grows, right? And when I say data grows, meaning, let's say at a large enterprise or any organization which is generating the data over the period of time, you will have the volume of the data. Volume, when I will say, the size of the data is going to grow. So example, let's say today you have the data size which is only having 1,000 rows. After 5 years, this data set has reached to 1 lakh rows. This amount of the data might not be easy to maintain in Excel, might not be easy to maintain in a workbook or a notepad or any another tool, which is, we have discussed earlier. So that is where, based on the volume, variety, and the velocity of your data, you must be choosing an appropriate tool also for the same. So that's where when it comes to the selection of the databases, we would be very much thorough about the, three V's which we have. So three V's basically, what is the volume we are expecting? What is the velocity we are expecting? And what is the variety of the data which we have? So with the help of these three V's, if we have understood that, volume. So volume is basically the size which you talk about. You might have the data which is of 1 gigabyte, you might have the data which is of 1 terabyte or anything. Okay. Velocity. Velocity is basically how frequently you are getting the data. Example, today you are getting the data with a volume of 100 million rows per second. Okay, I'm talking of very high number, 100 million rows per second. So your velocity of the data is huge. Okay, your velocity of the data is huge, right? Now, third is variety. Variety is you are just getting the data in form of a structured, let's say rows and column, or you're getting images, because images is one form of the data which we are getting today. Images you're getting the videos or anything else, or maybe one, or maybe there is a audio. So considering that, there are the chances that the data which you will get is going to be of the different formats. So having said that, now when we are choosing our database, it has to be very important that the needs of our business is being satisfied accordingly. So that is where three V's which we have, volume, velocity, variety, is also becomes a very biggest factor when we are choosing the database which we are going to use. Okay. So considering that, now I believe you have the fair enough idea that why we need a database. Okay. and what can be the use of database, and what are those things which you're going to consider when you're selecting a particular database, right? So coming back to the set of PPTs which we have created for you, what we have is we can see what is a database. Database is a collection of interrelated data which is used to retrieve, insert, and delete the data efficiently. It is also used to organize the data in form of table, schema, views, reports, etc. So now what we're trying to explain here is, as I said, database is basically going to organize the information for you in a structured manner. Structured manner in the sense, let's say that you have your candidates information into one system, and then you have your, let's say, employees information into another system, salaries information into another system. So considering that as there are the different systems are involved, if you have to integrate them together, if you want to retrieve is basically, let's say the data which I'm entering here, this data. On the end of the day, I want to view this data as well, right? The data which I'm putting into a system, either in an Excel file or either it is a database. Why do I need to take such a headache to put this data? Because I want to view this data. This data is going to help me in finding some insights about the information which I have. So that is where when I'm going to store this data, storage is not only the prime purpose of my data storage. I want to retrieve the data. Maybe I want to update the data also at a later stage. So the process of retrieval, insert, or maybe if this data is no more relevant to me, I want to delete this data also. So the process of retrieval, process of inserting the new data, process of deleting this data has to be maintained at a database level. And the database also should be efficient enough to handle that kind of the transactions or the operations which we want to do. So considering that when it comes to the database, we will say database is a collection of interrelated data which is used to retrieve, insert, and delete the data efficiently if we want to organize our data in form of a table. So what is a table structure? Now, when we talk about the semi-structured data, right? Semi-structured data example, you have this particular data, which I was just representing on my screen earlier. This is structured information where I am having the 6 columns, and then I have a one data row for those 6 columns also. This data set, when I will organize in this particular structure, this is a tabular structure. What is a tabular structure? Tabular structure is the one where you see the data in form of rows and columns. So we have 6 columns here, like candidate name, email ID, experience, gender, age, qualification, and then we have the one row for that. So anything which is vertically, you see these are the 6 columns, and here you have the horizontally where you have one. Storing this data into this particular format ensures that the data is into its best readable format. Okay, the data is into its best readable format. So a human or a program, when they want to retrieve this information, becomes much easier to retrieve and understand that information. So for the program, let's say for the backend program or the programming language, we might be able to store the data into the another format which is more efficient. But for a human who has to interact with this data on a day-to-day basis, it makes much more easy and readable when the data has been stored into the particular format of rows and columns. So that is where when we talk about databases, we would ensure that the databases are stored into the format where they can be read easily, they can be retrieved easily, they can be updated, deleted also easily. And the database also which we are going to choose. As I said, database is the platform which is going to store the data. And in today's market, there are the different platforms are available. Example, companies like Microsoft. So Microsoft has its own database product, which is known as SQL Server or known as SQL Server. Oracle is having its own databases, different versions, which as well as Oracle database like Oracle database, 11G, 19C, 21C, different versions are there. Postgres is there. Okay. Then we have our another database like from IBM DB2. Then from AWS, we have a columnar database, which is known as Redshift. So now the thing here is these different databases which are available, they are the different products. And when you choose a product, when you select a product, each one of them will have a certain capability. Okay, just give me a second, guys. Someone said that they're not able to join the session. Let me check once. Okay, we have few external participants also who wants to join. Sorry for the hiccup. All right, so as I was saying, right, these different databases which we have, basically these different products which we have, these different products is available and they are available into the market. Now, which product would you use, how it's going to be helpful, that depends on the multiple X, Y, Z factors which is there to us. But yes, there are the things which needs to be considered before we are selecting the database, like how much volume we want to store, how much information we have, what is the variety of the database, right? So considering that, the different factors are going to be into the place, which is going to be the deciding factor based on what database we will be choosing. Okay, so I hope everyone is clear about the databases and the use case of the database. We will be developing the different data models, which is going to provide you more real hands-on experience for the same. All right. Now, as we understand about the database at a high level, now we want to understand a database environment. I'm speaking so much about the database then, but the curiosity is, where is this database is going to be? Like, is it going to be in my system? Is it going to be in someone else's system? How I'm going to access this database? Another XYZ question. So to understand those things, let's talk about the concept of a database environment. A database environment is the collective system of components that comprise and regulates the group of data, management, and use of data, which consists of a software, hardware, people, techniques of handling databases, and the data also. What does it mean? That means that when we are going to set up a database environment, okay, as a part of this database environment, we will be having different softwares and hardwares involved, okay, and these different softwares and hardwares is going to help you in maintaining a database environment. Example, let's say what kind of a hardware we talk about and why we're talking about a hardware when we need a software, because on the end of the day, the database is basically a software. So why we're talking about a hardware? So hardware is required because these all softwares which we have, right? They need a minimum system, an operating system. They would be needing, certain RAM, which is our RAM size. We would be needing our certain, storage systems as well, so that a database can be installed. Okay, and whatever the storage we will do in a database, right? That is going to be return on our actual system which we have. Okay, so example, let's say I'm using a laptop here as of now. If my laptop does not have a free memory in terms of RAM and in terms of the storage as well, I won't be able to install the software. I need a running operating system. That operating systems can be a Windows operating system, it can be a Linux operating system, Unix, or it can be a Red Hat, or it can be Mac OS. Multiple different operating systems can be. So that is where when a database software has to be installed, it is needed a basic hardware to be available, and in that hardware and the set of softwares which is required, a database layer is going to be created. So what we will talk about our database management system is that once a set of softwares and hardwares is available, the user programmers are like the people like you and me who's going to program the data. So program the data meaning Let's say I have this Excel. So Excel is also can act as a database. But what software we are using here now to store this information? We are using Microsoft Excel as our software. Now I'm being a programmer here. I'm entering the values into our Excel. Okay. And now let's say you are the people who wants to read this data. If I will share this Excel workbook with all of you, and if you have the required softwares in your system, you would be able to open this particular Excel file and able to read this data, because this data which we have is in the readable format, which is it's into our alphabetic data is available. So that is where when we talk about a database environment, we need to have a software which is going to be database software. So either let's say if you want to use Excel, or you want to use Microsoft Access or any another software which you have, if you want to use, right? Based on that particular software, you will be able to, write the database programmings. Okay. You will be able to send the query. Query is basically the set of instructions which is going to go to the database, and then you can insert new information. You can retrieve the existing information. Retrieve meaning you will be able to take out that information and read it, or if you have to update the existing information, or if you want to delete those existing information, all that can be done once your database environment is ready. So in a database environment now, when you will be dealing with the databases, right, you will be, you need to get familiar with one more term, which is known as metadata. Okay, now what is a metadata? In short, in a layman's language, I'd say metadata is about data about data. You can anyone you will ask what is a metadata, first thing they will say metadata is data about data. And it's actually a complete sentence in these three words itself. Why so? Let's me help you understand. So when I'm writing something, let's say I would say my column name. Okay. My column name is candidate. This column name also have a name. Right. It is also, if I will talk about a candidate, candidate is a data also in terms of, because we are using the different English language, right? We are having the different keywords CANDIDAT candidate. Okay. Now, when I would store information in anywhere, leave about databases, just consider that you have joined. So my name is Sahil, right? I have 5 words in my name, and this is made of what? This is made of, 5 different alphabets. So whenever I have to store any information, okay, either let's say column name also is a 5-letter word. So even the information which even the column headings, okay, either the data types which we have. What is the data type now, and why I'm bringing it so early? Because Sahil is what? Sahil is the alphabet, right? So to store this information, what I would need, I need some technique which can store the alphabets. If I would just add here and I would say Sahil underscore Noel. Now what I need a technique which apart from storing this alphabets can store a special character also, right? So basically, when we have to store this information about the column names, about our data types, about the length of the information, this is basically all goes into the category of the metadata, because when you design the structure of a particular table which is having rows and columns, let's say this is the structure you have designed. So you know that in this structure, this can be a alphanumeric value. When I will say alphanumeric value, I would be meaning that we will be storing our alphabets and we will be storing our numeric values as well in terms of numbers, integers, etc., decimals. So I know that this has to be an alphanumeric value. Similarly goes for the email ID as well. Now, experience is something where I would be needing just numbers. Gender is something also which can be alphanumeric value or just can be a string value as well. Then again, the numbers, qualifications also which I would take is going to be. So if I have to categorize my data, you will see that I have categorized the data only into the two different data types. One is the alphanumeric value, and then the second is the number. There, primarily, when I have to categorize any information, I would personally categorize into three type of data types. First is a string or text or alphabet or alphanumeric, which is my favorite word to say. Then I would have the numbers. Numbers include integers, whole numbers, decimals, anything and everything. And the third one is a date, date or date time. Why so? Because when you look at universally, not just but when you look at universally how the data is being generated. So see, today is what? Today is 17th April. Okay, so that is a date. And the date can have a time as well. This program got started at 8 p.m. IST. Okay, so now in terms of a date, I can say I have the 17th April, 8 p.m. IST, right? So this is a particular format which we have, which is going to be accommodated by the date data type numbers. If I would ask in terms of total number of candidates who has joined the program as of now, I can see 46 is the number which I have. So now to store the 46, there are the two ways. I would write into an integer 46, or I can write into alphabet 46 into the English language as well. Okay, who is the instructor here? Sahil Goel is the instructor. So if you will see, this is the instructor name in terms of fields. This is the total number of candidates who turned up. And this is the session date. So considering these factors, if you will see now, to store this information also, you need this metadata to be defined beforehand, because if you don't have the metadata defined properly, you might get into the errors. Errors in terms of, let's say, I won't define the number of candidates as a, just a number data type. I would say that it can be a alphanumeric. Then as it can be alphanumeric, so today I might writing this as a number. Tomorrow, let's say there is a 50 candidates, and instead of writing 50 as a number, I would just write as a 50. So there is a conflict now. One time I'm writing the data which is into a number format. Second time I'm writing the data which is into, the alphanumeric format or just the alphabets. So this way we will lose the consistency of our data. So that is why when we define the databases, we would be defining our metadata also. Metadata includes the structural information. Metadata includes your column information. Metadata includes what type of information you are going to store, how much information we are storing in terms of how many records we have, and multiple other things comes as a part of the metadata. So that is where when we set up a database environment, we would be assuring that in one place we are storing the actual information or the information which is required for the user, the information which user want to retrieve. And in the second system or the database which we are going to use is going to store the metadata also, which is important in a longer run when we have to analyze the information. Because let's say I'll give you an exercise. Where would I ask you that please tell me how many columns we have where the data type of the columns is number. So that information is going to be available as a part of your database environment, which is available into the metadata. So that is why it is very important to understand that when we're dealing with the database environment, storage of information and the metadata both have the equivalent, you know, relevance into the system. All right. So that's how we are going to talk about and understand the database environment. Now, the other terminology, like what is a query? Why would I have mentioned a query and why would I have written a term called software to process queries? What is the program? Don't worry about it. We're going to talk in much detail what is the query. And if some of you already understand the query that I'm talking about, the SQL query, which stands for the structured query language, that's great. If not, then yes, we will have the separate dedicated sessions for that. All right. Here we are going to talk about a concept of database architecture. It's very important because what happens is, let's say that you are a junior programmer and you have been given a task to design a database. And if you are not aware about the architecture, okay, if you're not curious enough to know what kind of architecture you're following, you might be into a fix. So let's not be into fix. Let's understand that what is a database architecture and how it is going to help you also. So here what we're talking about is a DBMS architecture is depending on its design and can be of the following type. Now, first of all, DBMS is basically database management system. Now, when we are going to use the terminologies like DBMS, we are basically talking about a database management system. Okay. What is an architecture? Architecture is the view or the information in which it has been designed. So when you look at that information, you can understand the whole program and the project. Okay. So when we talk about the database management system, a DBMS architecture, we are basically representing that how we have created and designed the different views of that information so that end user can access it. What is end user? You can be an end user, I can be an end user. Example, let's say everyone have access to the e-commerce platforms, everyone have access to the social media platforms, everyone have access to the networking platforms also. At the same time, if you are a working professional, you would have been dealt with multiple different database environments also. Okay, each of these platforms will have something in common, that they are maintaining a database, right? Now, based on the requirement, every organization have a database architecture system which differs. Example, let's say when I'm dealing with the e-commerce platform, I would be having a user. I would be having an website where all the information has been listed. But at the back end, I'm maintaining that information also. I'm storing that information. I might be using n number of different databases to store that information, right? So considering these scenarios, what we are going to do is we are going to have you understanding that how a database architecture system is different and how it is important for you while you are working. So here what we talk about is end users are basically the external users who is viewing that information. Okay, so let's say that at inside, when I will talk about my Excel file, I have hundred of users, I have hundred of columns which I have created. Okay, and out of those hundred of columns, only five columns are the one which has been exposed to my external user, because other columns which I have created maybe is required for my internal usage also. Okay, I'm storing some sensitive information, I'm storing some backend information, or anything XYZ information I might be storing into that. So considering that, what we have is we have first is going to be the external view of our database management system. Then what we have is we have a conceptual schema, we have an internal schema, and we have the physical data organization. Conceptual schema. Now, what is this concept of the conceptual schema? What is the internal level and what is the physical data organization? Let's start with the bottom layer what we have. Physical data organization is the actual data which is being distributed across the different systems and stored at the physical level. Example, let's say I have these six columns with me, okay, where I have written the actual data, right? Now, these six columns I can distribute between the two sheets. Let's say I've added one more sheet here, and what I will do, this data set which I have distributed between the two sheets. So this is the real physical organization of the data, which can differ based on the system to system. So it's not really necessary that the data which you see on your screen as a front-end user or as an external user is exactly the way how the data has been stored into the physical organizational way of the data. It can be completely different. Meaning, let's say there are the one column which is coming from one database table, there can be another column which is coming from the another database table. So keeping that in mind, it is very important for a developer or for an architect to design the database management system from the point of view of the scalability, that how at the physical level we are going to store the information. So that's become the first thing which we understand, that how we have organized the data physically in our database management system. Then second thing is an internal schema. Now, what is the internal schema? Is internal schema would become the concept where internally I'm organizing this information into the different tables and how they are linked with each other. Now, I know that I have an internal view of this data where sheet 1 and the sheet 2 can be linked together with the help of a join, or with some methodology I can join that particular databases or the different tables which I have. That's become a internal schema for me. Third is conceptual view of the data. Conceptually, when I'm going to view the data, meaning, let's say that I have designed this internally, the data, look into this particular format. Now, when the end user wants to view this data and conceptualize this information, they don't want to see the candidate name as a candidate name. They just might want to call this as the name. Okay. When I'm saying the email ID, they don't want to see the email ID as email ID. They want to see the email address. Okay. Experience someone wants to read as a total number of experience. So if you will see how we are conceptualizing and making the end user to preview the data is based on the schema what we have, and it is different from the internally how we have organized the data. So considering these facts, the database architectures will help you in from bottom layer to top layer, how the data has been organized and how the information has been presented to the end user with the help of the different architectures what we have. Okay. So moving further, we are going to talk about something which is very important when it comes to the database. This is a three-tier architecture system. What is the three-tier architecture system is? The bottom layer which you see is a database. The top layer which you see is the application layer, and the final front end layer which you see is the presentation layer. Now, what is the meaning of this? Database architecture is basically the three-tier database architecture is where database is at the bottom, meaning any information which you are going to store is at the least layer at the database layer. On top of that, you will be having some applications which is going to consume the data from the database and provide the information form of presentation to the end user. Example, take a website. Okay, take a dynamic website where you will have a database stored into a PostgreSDB. You have a front end or application layer which has been built on your React or Node, okay? And then you have the front end tools like HTML, CSS, which is presenting that information to you. So that basically becomes a three-tier architecture for you. When you go to the complex applications, you have Oracle middleware, you have Microsoft middleware, different application comes into the picture. But to keep it simple, if you have to understand, database is going to store all the databases related information. On top of that, you have a programming interface which can interact with the data and provide that information to the presentation layer, which is the front end layer. Because presentation layer or the front end technologies which we have, we don't want them to interact directly with the databases. We want to have a middle layer and application layer, which is going to interact and connect us with our database which we have. So that becomes a typical three-tier database architecture. When we will deep dive into the concept of ETL and the databases, that's where we will be having the real crux of it. Moving further, okay. So then till now, what we have discussed, if we have to summarize it, we are trying to understand the use of databases, okay, why the databases are there, how it is going to be beneficial for all of us, and these database systems which we have, how they work. Okay, so now As a part of the database management system, we know that database is going to be used to store this information. Database, when store the information, they will be building the metadata as well, right? And we can organize the information in such a way that database can help us in the faster retrieval of the information. Okay. Now, when we have to organize our information, right, we would be needing a mechanism which can help us in providing the relations between the information what we have. Okay, what does it mean? Consider, let's say this particular Excel which I'm using right now. If I would have to make any changes to this particular Excel, it becomes very easy, right? In terms of either have to edit any columns, I have to add any columns. It's pretty easy here. Okay. Plus, at the same time, I cannot introduce any constraint on this. Constraint in the sense, I want to make sure that if I'm making any changes to the structure, and if that structure does not pass the certain XYZ condition, this changes should not be allowed. Correct. So keeping that in mind, what we have is we from the DBMS system, okay, from a DBMS system, we need to now move to a relational DBMS, which basically stands for relational database management system. Now, how the relational database management system is better than the database management system what we have. As I said earlier, database management systems is going to be used to store the data, okay, in a certain way. Database management systems are not meant to store the data where you have a lot of relations available. Example, let's say you must have, take any example. Let's say, an employee example only, right? Let's assume that you're all employee of an organization. It can be in any XYZ organization. So as a part of that employee, okay, when you join organization, company are going to capture certain information from you as an employee. They will be capturing your name, which we can call it as the first name, which we can call it as a, then we will be capturing your name, its last name, then they will be capturing your date of birth, your current location, your qualification, okay, your gender, XYZ, and your mobile number, your personal email ID as well, right? So these become a set of information which is going to be captured at the organization level, right? Now, when the organization is capturing this information, it's going to be shared across with the different departments. How your salary is going to process. Each individual will have a bank account. Okay, so when they're capturing, they will be capturing your bank account information also. Okay, now they will be capturing on the day-to-day basis, they would be capturing how many days you have worked, right? Because that information has been sent to the finance and the admin department, so they can create your payrolls, they can generate your salaries as well. So if you look at an employee at it whole is individual is having a lot of information linked to it. Okay, now this information can be associated with the different other sets of information which we have. Example, employee, when before onboarding an employee into an organization, employee would be needing a department in which he or she has to report. So first, what an organization has to do, they have to create a department. Okay. Now, department in its own is also having a meaningful information which is their example. We'll have a department name. Okay. We'll have a department description, that what kind of a work it has been done by the department, how many number of employees are working in this department, XYZ, right? So now the idea is when I want to make sure that that before onboarding an employee, I need to make sure that the department exists, right? So even if the department is going to exist before an employee is coming into the picture, my database management system, I can establish a correlation between them, or how can I have a relation between them? Now, to create those relations, I cannot use my Excel as a system because it's not going to support. Excel is not meant for that purpose. That is where we need to make sure that we can establish the relations between our system. We can have the systems which can handle this kind of a use cases. The relational database management system was introduced. In the relational database management system, we can have the relations between the tables which we are creating. We can define the constraints on what. So constant is what? Let's say that someone is, put a constraint. Basically, they're stopping me to do something, or they're stopping me to do something in a manner in which it is not allowed. So similarly, when we put a constraint on our database, we are putting a set of rules. That rules are the one which is going to make sure that the database management system works in a particular way, right? So considering that, now when we are talking about the relational data model, we are basically talking about the set of techniques, or the structuring data techniques using which we are going to consider the data in form of rows and columns. The data is going to be structured, which is going to be surrounded and is going to be stored in form of tables. Each relation has a name. Basically, the relation which we are going to create is going to be known as attribute or column, and each tuple which we have is going to hold one value per data. So what is a tuple? Basically, this data set which you see, this is we are calling as a tuple. Okay, so when it comes to the relational data model, basically we will be using a set of techniques using which we will be defining the relation between the different set of tables, and those set of tables is going to have a specific constraints using which we will make sure that our data remains in that structure and it's going to be provided accordingly, right? So considering that, we will be discussing on the relational data model, right? So let's take a quick 4 or 5 minutes break. I know it was an extensive 1 hour session. Let's take a 5 minutes break. Once we come back, then we will move towards the relational data model in more depth. All right. I'll start the session again in the next 5 minutes and we will proceed from here. Thank you. Hi.